Hi there. Welcome to our presentation on UML component diagramming. My name is Matthew McGuff, and I am a software engineering major at BYU, Idaho, along with Tyler Hansen, who is also a software engineering major. We'll be discussing the design technique of UML component diagramming. UML, or Universal Modeling Language, is a structured method of representing design relationships. The language was developed out of a need for people to communicate complicated relationships in software in more expressive and descriptive ways. There are several different types of UML representations. UML component diagramming deals specifically with the physical components or artifacts of a software system. Next slide. UML component diagramming can be broken into four main purposes. One, modeling the components of a system. Two, modeling a database schema. Three, modeling the executable of an application. And four, modeling the system source code. Modeling component relationships, especially in enterprise level applications with thousands of lines of code or thousands of or hundreds of different tables and different relationships, is extremely difficult. They say a picture says 1,000 words, so diagrams such as component diagramming provide a wonderful way of expressing these relationships in a way that those that are new to a project can gain great understanding in how a system is working from the top down. Let's take a look at an example of an application um, of UML diagramming in action. Next slide. Here we have a component diagram for a system that gets the latest Billboard top music statistics. The, the, the reporting tool in the middle makes a call to the Billboard service artifact through SOAP over HTTPS. That's represented by that dotted line. The collected data is then served from the reporting tool to the servlet API, and also sent to the Java Database Connectivity API, or JDBC for short. In this example, we see each component, and each component is comprised of subsystems that together have a relationship with another component, as illustrated by the dotted line. This helps us understand what role each part is playing in relation to the whole. Now we'll have Tyler explain to us some of the upsides and downsides of using this design technique. Next slide.
All right. Now, with any real aspect of software development, there's going to be some upsides and downsides. Now, this one's actually a very useful tool to use when you make the diagram correctly. Component diagrams are useful communication tools between various groups. It's a really good way to pass things around and get a real feel for how the actual architecture of the actual program or application is going to be working. Now, the diagram offers natural format to begin modeling a solution. Component diagrams allow a developer to verify that a system's required functionality is being implemented by the components, thus ensuring the eventual system will actually be acceptable. This project could also be used to shown. This can be used to shown to key shareholders, so they can get a real feel of where the actual planning stage is at. This can generally put shareholders at ease because it presents an early understanding of the overall system that is being built. Also, developers find the component diagram very useful because it provides them a high-level architectural view of the system that they'll be building, so they can early on begin formalizing a roadmap for things such as implementation, and they can make decisions about how they want to assign tasks and get that done. Similar to that, system administrators find these diagrams very useful because they get an early view of the logical software components they'll be running on their systems. Next slide. Now, the real major downside of the diagram is there's only really one. If it's done correctly, it's a very powerful tool. But if it's done incorrectly, then it can actually be more detrimental and helpful. It can set the team in the wrong direction. It can give an inaccurate view of the way a system works. So things such as implementation later on could be mishandled because you're not sure exactly how the components work together. It's just as long as it's very important that it works correctly, because if you do it wrong, then it's going to be a major hassle on the system rather than a help. But that's really the only, as long as you do it correctly, it's a very powerful tool, like I said before. Now, as a quick recap of our presentation, like I said before, the UML component diagrams represent the physical artifacts, or in other words, the components of a system. And this diagram shows the way that these components work together, or the relationship between them. And when in the example earlier, you saw that the way that's notated is you have the actual name of the component, and then the components that it uses represented by a dotted line. And on the end, on the side where the components is being used, it shows the hierarchical relationship of what's using what. Also, the four main purposes of this diagram is some levels of modeling. You model the components of the system, you model the database schema, model system source code, and you model the executables. That way it really keeps in hand. Like I said, later on when you get a really big project, it's really easy to get lost in it, where early on, if you have this good diagram set up, it's very easy to follow what works with what. It's a very powerful tool and it's really helpful to know between each other. All right, and so that has been our presentation. If you have any questions, here's actually some of our references. The first two were talking about actually UML component diagrams themselves, and the second one is also a little more into the UML part of it itself more than the diagram. And the last two are a couple images we used in our video. And if you have any other questions or you want to know anything more, feel free to let us know.